Hey guys, it's Vince. Today in this video, we are continuing with volume number 19 in the CNC fail video series. And what makes this video very interesting is that the YouTube content creator I featured last week in volume number 18, he actually did a correction video, supposedly, where he went over the system to eliminate all the EMI issues he was experiencing that justifies and validates exactly what I explained in last week's video. So if you haven't seen that one, at least watch that video and you can see, once again, almost like predicting the future, I go into great detail explaining what issues you will have. And this video is of him supposedly correcting these issues. Let's jump right in and see how well he did.
So in this video, I'm going to run you through the previous configuration real quick, and I'm going to show you the changes I made. So one of the first things I did was I replaced the plastic box that was on the back of the Y-axis with this metal project case.
Okay guys, we see the first upgrade that he's working with. He went from an electrical enclosure that was plastic from the previous video. Now he's upgraded to a metal electrical enclosure. Now first and foremost, you can tell that this is really not an electrical enclosure that's large enough for the capacity he's working with. It's very, very small, and I highly recommend you take that into consideration when you're working with your system. You want something you're able to work in easily, because if you have to service it, it makes it much easier. The next thing you're going to realize is that if you do your homework, and I hope many of you do, for my novice guys out there, using an electrical enclosure made out of metal with CNC robotics is always going to be best practice, period, because it will help mitigate EMI in that it forms a Faraday cage effect around whatever is enclosed within it. On top of that, it also adds the extra benefit of providing the most sturdy platform, with the added benefit on top of that of not being a flammable substrate. This is something to keep in mind for safety. And another key point I want to address as we go through this video is keep in mind how much time it would take to upgrade this robot, because what was done originally in the previous video I featured was done incorrectly. There is no such thing that there's a free lunch with CNC robotics. If you guys think you're going to get away by cutting corners, most of the time you're going to end up going back, as this end user did, and decide to upgrade. He calls it, when realistic terms means that the robot was not stable to be used. Henceforth, it was basically a paperweight, and therefore these upgrades had to be done in order to make the robot usable. Factor in the time, factor in the money, and you will see it's always better to do it right the first time, even if that means saving a little longer.
All of the leads from the motors and from the limit switches are looped through various ferrite beads that I've collected over the years.
Okay, here's a question I get asked at least 3 to 5 times a week, and that is, can I just use ferrites instead of using double shielded cable to mitigate EMI? Now, the answer to that is possibly. Let me explain. If you're using a ferrite under a short distance, yes. If you're using a ferrite under the pretense that a shielded cable can be mitigated due to the fact that you don't want to run a 12 to 14 foot cable, that's not going to work for you. Ferrites are only going to filter a very short distance. And what we see here, where they're actually filtering inside the terminal block as far as the connections going in, that's fine. The issue is he's not filtering anything where the switches are making contact with the machine. So while he may think he has stability now, remember this, and this is something many end users forget. They say, oh, my machine's stable right now. Well, it may be stable for a certain cut. The thing with EMI is it's very, very arbitrary in that it's random. You may be okay one day for cutting and the next day you're not okay. So these are things you need to keep in mind. That means that the only way to mitigate EMI properly from that arbitrary response of it being so random is to utilize the best principles possible. That means double shielded cable on every accessory that requires a critical signal. If you're going to design a junction box, as this end user did, what you would do is actually have the double shielded cable still being used on all your switches coming to the junction box where there is a ground bus within the junction box and then a master cable that will be connected to your controller, and once again going to the inputs within the controller to actually designate the switch signals. This is best practice. This is never done because it's much more cost effective to just do it right the first time, just running the switches directly to your enclosure rather than using junction boxes. So again, these are principles that are seldom discussed, and we're seeing once again what's not to be done in best practice. Hopefully he did find stability. The truth of the matter is you'll never know, because most of these content creators will stop doing videos on this type of content to show you over duration how this table performed.
They go into this terminal block. This terminal block was something I stripped out of my Bridgeport CNC machine when I converted it to run on Mach 3 in a PC. And then these connections all go into this cable. This is an 18 conductor shielded cable specifically made for automation and mechanical controls. I did have to buy this. I didn't have anything in stock.
Okay guys, once again we see a critical mistake of details being made. And let me explain. Most YouTube content creators, and I've said this in previous fail videos, they brush over areas they don't understand and cover areas they understand pretty well as far as detail. As soon as you see the detail lacking, you already know it's something that they don't understand. He never covered allocating this shielded cable's drain to any ground bus. Without that allocated drain going to a ground bus, basically you have a cable that is not mitigating EMI. It performs just like a regular cable. This is why I tell you it's critical to deal with a professional in the industry that understands this type of engineering. If you're dealing with just novices who are kind of playing with, just images online and dealing with wiring schematics and just testing components, they think under the pretense that they bought a double shielded cable, that I'm using double shielded cable, everything is right once I wire it up. It's only right if you buy the tool and implement it the way it was designed correctly. And this is something that, again, level of detail training goes into, and applying the theory and the training, that's when you get a stable system. Unfortunately, his audience, once again, watching this, they think, oh, well, he did this, so I'll just buy this cable and everything is miraculous. If they don't connect the shield drains properly, guys, the cable will not mitigate EMI. This is why I tell you, beware of these content creators.
Usually I try to use absolutely everything I possibly can from my junk bin, but the idea of stringing together and then shielding 18 conductors into some sort of monstrosity of a cable didn't appeal to me, so I did order this.
It's really interesting to hear how he came up with he needed this cable, and I hear a lot of end users do this. YouTube content creators like this individual do it because it makes entertainment, and that's what I mean by entertainment videos, guys. You should be selecting the proper tools to build the system, which double shielded cable is the proper tool to use when you implement it correctly. When you're looking at a purchase just simply because you don't have anything in stock that you can somehow substitute, that becomes really frightening, and it really becomes a line of danger that you're playing with. I'm telling you now, do things right, take your time. Everybody goes through rough times where they're trying to do something correctly and they may be short of funds. There's nothing wrong with saving. I have a lot of potential clients come to me and say, I'd love to buy your equipment, I just don't have the money. That's fine. That should be the way it is. It makes you work harder, makes you work smarter, makes you appreciate things more. And that's something that I always find is that clients that actually do save for their equipment to do it right, they take care of their equipment in a different way because they respect it more. This is something we tend to not see when we hear terms like this being used. The individual should have said, I purchased a cable because the machine required it, and I expect this machine to perform a certain way. And it requires this tool to perform that way. That is what ultimately is always lacking in all of these quote-unquote entertainment videos.
The next part of the process was to take all of the electronics that were in that plastic box and put them in a metal box. This particular chassis, this came from a company I used to work for. I think it held a spectrometer of some sort. It's a nice heavy-duty aluminum case. And let's take a look inside. So everything I possibly could, I put inside this case, including the power supply for the laptop and the main power supply that drives the stepper motors.
Okay, guys, I want you to pay close attention on what I'm about to explain here, because for some reason, the consensus from all these YouTube content creators and many other CNC end users for that matter feel that everything with their CNC controller should be driven around neatness instead of driven around a stable robot. Now think about what I just said. When you're engineering anything dealing with a production robot, the main function of that robot, the optimal function, is that you're designing something that's going to provide stability. It's a production robot. Don't give me this crap, it's a hobby robot. Don't tell me it's a professional robot. You both end users, and I'm talking about both swings of end users, expect that robot to produce accurate results. That means we need to look at this piece of electronics as a sensitive piece of electronics. This is where guys go wrong. They think they're building a PC or a speaker box, and they think that, just by incorporating as many components as possible inside the electronics enclosure, be it a VFD, be it excess power supplies. In this case, this individual decided to mount the laptop's power supply inside there. It's trying to make everything neat instead of thinking about, if I do this, the chances of me troubleshooting any potential EMI is just increasing. Keep your design neat. Neat meaning essential. I've said that numerous times. I get asked all the time, can I install a controller inside of the electronics enclosure? You certainly can, but just keep in mind, if you do that and you do encounter a problem, you're enhancing your troubleshooting effect. So we know that you're going to spend more time troubleshooting than making that a subsystem. These guys simply do not understand that concept. What they do is put a whole bunch of crap inside of a metal box, and what they're essentially doing is, and what this individual did, and many ones like him, is they're trapping all of that electrical energy, EMI, inside of that enclosure surrounding all of their critical electronics. It's done with VFDs all the time. It's done typically with as many accessories as they put in that's taking power. It's doing the same thing. And the effect of an electrical enclosure, when you're actually trapping your electronics inside by producing an exterior Faraday cage effect, works in reverse. When you put excess electronics in, also drawing power, you're basically trapping all of that extra EMI around your units. This is why this whole concept of neatness should not be based upon how much you can stuff inside your electronics enclosure, but should be based on building an electronics enclosure that's neat by the fact that only is being housed within it the components that produce a stable robot. Listen to this portion of the video again, and you will find out why so many guys have so many problems. I cannot tell you how many of my potential clients message me, hey, I've built this. They'll message me a vague message, then I cover with them the message that they sent me, and what they end up doing is basically sending me a picture of just a controller that is just a mishmash, hodgepodge combination of whatever they found in their shop that they can install, and they can't even diagnose it themselves. They don't know where to start. On top of the fact that now the controller's built, all the work is done, so now they have to backtrack and try to figure things out because they didn't do the prerequisite work to understand the concept of what they're working with. Why? Because they didn't contact the right professional. They could have saved them a lot of time and a lot of money. Make it as simple as possible. Keep things in subsystems. The more you integrate inside your controller, the more troubleshooting that is required to be done and the more knowledge around that troubleshooting. We're already talking about a difficult topic. If I make it more difficult by incorporating more and more components inside the enclosure that you may or may not understand, it's just leading you down a rabbit hole. 98% of end users service their own systems. If you watch this portion of the video again and really digest what I'm saying, you see how critical it is to understand what you're working with. It should never be a goal for you to just assemble the controller or make things look neat. That's what these guys all want you to believe. It's all about neatness. Neatness only counts if the robot is stable. Think about what I just said.
So let's unplug the laptop and take the cover off. And what we have inside is we've got our X, Y, and Z stepper controllers. Down at the bottom, we've got the 24-volt power supply. We've got a 24-volt fan here. The power supply for the laptop is down there. And this is the USB Mach 3 controller card.
Here is something that I find truly amazing, in that when content creators say they're going to revise a past build or upgrade a past build, you would naturally assume as their audience that they did some research. They found some more knowledge and acquired that knowledge and are going to implement it, other than just base level stuff like using a metal enclosure. In this particular instance, and I've seen this done by many content creators, I'm sure many of you have, he's just found an enclosure that he thought he could fit his electronics in, and he just mounted the electronics and calls it done. Put a fan in there, I'm done. Unfortunately, what he forgets is details count. This is not a computer. This is not just an arbitrary electronic build. This is a CNC controller. That means all of the components that are within the electronics enclosure you've selected, even though it's metal, we want to make sure that they can breathe properly, because there's enough air volume inside of that electronics enclosure to support what we're doing. Now, something else to point out about the size of the enclosure you select, and I want you to think about this. If the enclosure you select is too small or just large enough, as we see here, to fit the components to be mounted within it, the thing to realize is all of that electromagnetic energy that we've discussed, where the Faraday cage effect becomes effective externally, and I've already discussed becomes in a reverse format effective internally, in the sense that it will condense all of that EMI around your sensitive electronic components. If the box is small, it amplifies that even more, because that energy is condensed around all of the components mounted within it. A lot of this should, I feel, just be common sense. If we condense the space to the components we're working with, then essentially what we're doing is condensing energy around these components as well, just like we are with heat. So these are things to think about. Now, once again, when I say details count, he did say he actually mounted a cooling fan within the enclosure, and that's great. The thing he didn't cover is what is the cubic feet a minute, or CFM rating, of the fan. Is it adequate enough to support 3 stepper drives, 2 power supplies, and the breakout board? If it's not, let's say he selected a 24-volt fan that's only putting out 30 cubic feet a minute, it's barely breaking a sweat to cool this amount of electronics. This is where you have to understand what you're working with. All details count. And guess what happens if he decided to mount the incorrect size fan? Once again, not providing adequate cooling, we once again have the possibility for an unstable robot. This is why I'm telling you, every detail counts, let alone the fact there is absolutely no wire management going on here. And I see that once again with a lot of content creators. To them, it's all about producing a video to get uploaded to YouTube to get those clicks. They could care less, once again, about your definitive success. But they have no problem showing that they're making you interpret that they're successful with what they've built. And that, to me, I will never understand. Many of you don't get it. But looking at this, it just keeps going down that rabbit hole of, I wanted to get something done to provide more content for the channel, regardless of if it was done actually correctly, with research being done, because this information is all available online.
So I actually looked up some of the prices of these on Amazon, and the controller card is about $20, and these stepper motors, if you buy 4 of them at once, these are $10 each.
And the clicks go up as the prices go down, and I want you guys all to think, first and foremost, he's calling the stepper drivers the stepper motors. That should be a definitive red flag. But if he's paying $10 per drive that's controlling this robot, and then he's paying $25 for a USB motion controller. Once again, USB has all kinds of stability issues. I've already posted numerous times about the stability issues. I'll put the email in again. I'm sure all of you have seen it in all my past videos, direct from Balzis, from CNC Drive, lead engineer, who released the UC100, and you can see how many stability issues this controller has. Ask anyone who's using it, or better yet, do a Google search on these controllers and see how many people have problems with stability. And yet he defines the quality of the system by saying how cheap components are. Shouldn't it be the opposite, guys? Shouldn't it be that, hey, I've put in the amount of research it takes to get the job done using the correct components and selecting components naturally that are within a budget, but within a reasonable budget? I mean, $10 a component? What kind of quality are we getting in this genre? I mean, I want you to think about that. I think that these content creators really need to assess the logic behind what they're saying. Me bragging about putting a roof on my house for $200 on a 3,000 square foot house, many of you out there would be laughing, and you'd be justly so. What are we to think in this genre when something like this comes up, where we keep reiterating we've paid a ridiculously low price for components that are essentially the brains of your entire controller? Makes no sense. Maybe it does to you. I'll never understand it.
So my electronics are actually cheaper than originally I thought they were. On this box, the wires that come in and out of the box, I've added ferrite cores here and here. The Mach 3 controller also has some additional shielding by virtue of the fact that it's on this suspended plate.
I'm not sure where he came up with extending the height of the USB controller he's using will somehow enhance its shielding capability. This is certainly not true, guys. And once again, he's just throwing crap to the wall to see which sticks. I don't know where he got that information, but the bottom line is this. EMI mitigation through distance is possible, but it certainly isn't going to be 2 inches elevated off the base of the chassis. Let's think about what we're looking at again, and this once again is just really drawing straws as far as where he's going with this.
Take this plate off and show you the filter capacitors at the bottom. There, down at the bottom, those are the arrays of filter capacitors. Every single lead from the cable that comes from the plasma table connects through these boards, and these little tiny capacitors here, these are 4700 picofarad capacitors, and they connect each and every single one of these wires to ground.
Okay, guys, let's discuss a little bit of philosophy here, and hopefully it'll translate in terms of the way I think to the way hopefully many of you think. Whenever it comes to engineering, I always believe in looking at the best. If I'm looking at the best companies that have engineered products that have always worked, and I can mimic what they've done, then I know that my success is ultimately almost guaranteed, pending, of course, I understand the principles involved and the adequate budget to achieve that. Now, saying that, I want you to think about something. I always quote Lincoln's PDF manual when it comes to EMI reduction and grounding. Why do I do that? Because I know the company has been around well over 20 years. They understand this technology to a level that far exceeds that of most end users, nor would they ever need to. And then on top of that, they have virtually unlimited resources. They not only manufacture plasma cutting tables, they also manufacture plasma cutters and welders, and they've stayed in their industry because they've mastered it. Now, I want you to think about you following those principles from, once again, a top-tier company like that, and then you design your plasma controller ultimately using what their engineers do with their knowledge level and using their manual as guidance. Do you really think that you would go wrong, pending once, of course, you understand the budget related? No, I don't think you would. And I think many of you understand that point of logic. The interesting point is this. Content creators like this, once again, turn their machines essentially into a science project. He put a filtration system in this controller, and he's claiming that, of course, the system is now stable. I want you to think about this. Are we to believe that Lincoln Electric's resources aren't available at the term level that this gentleman's is? It would make no sense. If they really felt that all they had to do was put in a filtration system in their controllers, I believe it's safe to assume they would implement that. Why don't they? Because they understand that double shielded cable is the only correct way to mitigate EMI and do it in a stable sense, not a gambling sense where we're saying, hey, we're just testing this as a theory, let's see what happens. That is the difference. If you understand this philosophy I've just explained to you, you're already 10 steps ahead of any content creator, because that's where they drop the ball. It's always more interesting to see a different way of doing things than to see a wheel that spins perfectly round and gets you to point A to point B. It's been around forever. It works great. Why do we change it? Again, if it's not more efficient, if it's not costing less, we don't change it. Stay with what works, stay with what's tried and true, and best of all, mimic the top companies to the best of your knowledge, the best of your budget, and I promise you, you will not be disappointed. Okay, guys, that wraps up volume number 19. And once again, I want to thank everyone for their support. I want to wish everybody a very happy, safe Easter. And if anything, I hope that these videos keep making all of my guys out there do their research. That's all I ask. Once you guys do enough research, it'll all become clear. Anything that anyone, especially content creators, try to make simple, just be careful of that. Some things naturally can be made simple. Other things are not as simple as many believe, especially when it comes to CNC. Everything is easy in a 15-minute format. When you're building it and you're going over it yourself, that's when you find out just how easy it is. Thank you all for your support.